Let's dive into this topic in a simple and clear way. What is standard deviation? Standard deviation is a statistical measure that tells us how spread out or close data values are from the mean. In simple terms, it shows how much variation exists in a dataset. If values are close to the average, standard deviation is low. If they vary widely, it's high. It's used in research, finance, education, and many other fields. Understanding with a simple example. Imagine you have 5 students' marks: 50, 55, 60, 65, and 70. Their average is 60. Now we want to know how far each score is from this average. Standard deviation helps us measure that difference. It reveals how much the data is spread out from the mean and gives a more accurate understanding of the dataset. Before calculating standard deviation, we need to find the mean, average, of the data. To get the mean, add all values and divide by the number of values. For example, if your values are 10, 20, and 30, mean equals 10 plus 20 plus 30, /3 is equal to 20. This mean becomes the base to measure deviations. What is deviation? Deviation means the difference from the mean. You subtract the mean from each data point to find how much it deviates. For example, if the mean is 50 and a value is 60, then deviation equals 10. If the value is 40, then deviation equals -10. These deviations help in calculating the standard deviation. Why do we need standard deviation? Sometimes 2 datasets may have the same average but very different spreads. Standard deviation helps us understand how consistent the data is. For example, if exam scores are tightly packed around the average, SD will be low. If scores are very different, SD will be high. This helps in interpreting data reliability. In education, standard deviation is used to analyze student performance. If the SD is low, it means most students scored close to the average. If it's high, students' performance varies widely. This helps teachers understand classroom earning levels and identify gaps. In research, standard deviation tells us how reliable or variable our data is. Lower SD means stable data. Higher SD means inconsistent results. Standard deviation can be calculated for an entire population or just a sample. For population, we use the total number of values n. For a sample, we use n1 instead of n. This small change adjusts the formula for better accuracy in sample-based studies. The formula for population standard deviation is sigma xa mi n, where mu equals mean of the population, 11 equals each data point, n equals total number of data points. This calculates the average of the squared deviations and takes the square root. For a sample, the formula becomes S sigma xi x n n, where x equals sample mean, n equals number of observations in the sample. Using n1 instead of n helps make the result more accurate when estimating for a whole population. Here's how to calculate SD. Find the mean. Subtract the mean from each value. Square each result. Add all squared values. Divide by n or n1. Take the square root. And there you have the standard deviation. On a graph, standard deviation shows how far points are from the average line. Low SD equals points close to the mean. High SD equals points spread far from the mean. Visualizing this helps in comparing datasets and identifying outliers. If all data values are exactly the same, then the standard deviation is 0. That means there is no variation at all. For example, if every student in a class scored exactly 80, then SD equals 0. This is a sign of perfect uniformity in the dataset. A high standard deviation means the values are widely spread from the average. This indicates more variation in the data. Low standard deviation means the data points are very close to the mean. This suggests high consistency and reliability in the data. Both standard deviation and variance measure spread. But variance is the square of the SD. Variance is not in the same unit as the data, while SD is. Today, calculating SD is very easy using tools like Excel, SPSS, or scientific calculators. In Excel, use the formula equals stdv.s range for sample SD. SD can also be used in libraries. If you found this video helpful, don't forget to like, share, and subscribe to Library Facts. Thank you.